Good morning, everyone. Happy Wednesday, and thank you for joining us for the May webinar, NTSA Tech Grove Connect. We do this webinar over 7 months, each month for 7 months, highlighting the story and the team and the innovation embodied in the best papers from IPSC the previous year. This month, we're going to hear about a really exciting innovation that emerged out of some work started at the Air Force University, and we are very fortunate to have a great team with us today to talk about that. Before we get started that, I just want to say a few words about Central Florida Tech Grove, because many of you who are joining us today may not be familiar with Tech Grove. We are anchored in Orlando, Florida, in the heart of DoD's modeling, simulation, and training commands and acquisition activity, a huge industry cluster here, a lot of academic work that goes on. The Central Florida Tech Grove was created about a year and a half ago as an innovation center and an innovation hub to build on the extraordinary collaboration represented by Team Orlando here, and to bring together audiences much like we have online today, industry, academia, government from all across the country and even beyond, to bubble up to the surface, if you will, new and innovative and non-traditional ways to solve problems and meet the needs of our warfighters out there. As you see on the screen, we have a number of government customers for Tech Grove, 6 currently: the Naval Air Warfare Center Training Systems Command, the PEO STRI, Executive Officer of Training and Simulation, Air Force Agency for Modeling and Simulation, the Marine Corps Training and Systems Command, Army Futures Command Synthetic Training Environment, and the Army's Simulation and Training Center as well, and more on the way. A lot of activities that you see captured in the pictures there, everything from pilot training next, simulators actually sitting here in Tech Grove for you to come in and do some innovation and testing and evaluation and demonstrations on, our monthly juice bars, our game jams that we have every year, and lots of other activities going on and opportunities for you to engage. This is where we're focused. And you see the 3 main areas there, all embodied, or certainly cybersecurity and human performance woven through all of that. And underpinning these 3 focus areas are a whole lot of enabling technologies and capabilities that you see listed below. And then we'd love for you to connect with us. Follow us on LinkedIn. Go to our website and fill out that contact form if you haven't already, so you'll be in our database and get messages about our events. And I'll put this slide up again at the beginning. So with that, I am going to turn this presentation over to Dr. Andrew Clayton from Air Force University, who really led this effort to create this really innovative approach to figuring out what form of reality, non-reality, do you select for training and simulation, and how do you know which one? And I'm going to ask Andy to just briefly tell you who he is, and then Lieutenant Colonel Tracy Smith and Major Carolyn Price Moore, if you will each just tell us who you are, who you're with, and who you are, and then we'll move on into this fascinating story. So, Dr. Clayton.
Awesome. Thank you, Carol. Good morning, everyone. My name is Dr. Andrew Clayton. I work at Air University as assistant professor of leadership under Air War College / the Leadership Institute, but I'm also the director of Immersive Learning and Simulations Research Task Force, which stood up about 2 or 3 years ago and is in partnership with AFMS as our sponsoring partnership. That's kind of who I am in a very short sentence there. So let me pass it over to Lieutenant Colonel Tracy Smith to introduce herself.
Good morning. I'm an Air Force pilot currently working at the 19th Air Force in San Antonio, Texas, which owns all of the flying training programs for pilots and other winged aviators. My job's chief of curriculum development right now, so we're working to incorporate a lot of modern learning methods and new technology into our programs.
Good morning. My name's Major Carolyn Price Moore. I also work at 19th Air Force with Lieutenant Colonel Schmidt. I'm an aerospace physiologist, and I primarily work on the Comprehensive Readiness for Aircrew Flying Training Program, which is our effort to put human performance optimization embedded into our flying training pipelines.
Awesome.
Thank you. And on the phone, we have Mr. Russell Hutt, who is with AFMS, the Air Force Agency for Modeling and Simulation. So Russell, if you'd like to introduce yourself, please.
Yes, hello. Russell Hutt from the AFMS Air Force Agency for Modeling and Simulation. We are a field operating agency off the air staff. We report to HAF A3, which is operations. Our focus is training and readiness, and we are the sponsor of this effort. Over.
Thank you. We'll hear from Russell certainly throughout this presentation as well. So with that, Dr. Clayton, how did this all come about, and why this team? What happened here? Tell us the story.
Great. Yeah, thank you, Carol. Absolutely. Let me. I'll start with a story as we go kind of back, and where this kind of came from was really a project that started under a company called C-Square Technology as we started in our maintenance train X assessment. And so when maintenance train X kind of stood up, C-Square Technologies was brought in as another company to do the assessment on how well the kind of the first prototype of maintenance train X was going, bringing in VR into maintenance training. And then we'll see how it kind of flows into the other aspects of 19th Air Force and where the future's at. And so how that actually started was this connection with the research task force at Air University. And so Air University has a research task force where students in Air War College and Air Command Staff College can take a pretty extensive course on the use of immersive learning, AR, VR, XR, AI, haptics. As you can see here, lots of things are covered in the research task force. And these pictures actually show students actually in VR in classes doing things. And from this research task force, we actually had several partnerships with different VR, AR industry companies. First, our partnership came from AFMS. So AFMS actually funds and supports the research task force at Air University. And so the research task force has to have a sponsoring partnership, and AFMS recognizing the benefits of having students, those from the Air Force, that get to come to Air University for a year and think about deep things such as virtual reality and immersive technology and how it can be applied in their operational units and in their career fields. It would probably be good to sponsor that and support those students doing that research. And so that's kind of how that started. And then from there, connections through AFMS and our RTF, we made connections with C-Square Technologies, which was given the contract to do the assessment on maintenance training next. And so from that assessment, I was brought in as part of the RTF to do some consultant to help C-Squared in that assessment. And so that's kind of how we started this connection. And as we started looking at maintenance training next, we started to see all the different organizations and companies that are actually building maintenance training next. And you can see here on this slide several different immersive learning technology companies were actually part of creating the maintenance training next program. And you see here Dynamic creating kind of the management software, the use of the MOTAR dashboard, the curriculum development. And then you see HX Labs developing some of the VR simulations themselves using 360 videos, and for students and instructors to be able to look at the tasks that they're actually doing, all the way to the VR lobby. So as you go into the headset, the lobby that you go into, developed by HCX Labs, and then Ario and Corp Incorporated bringing in some of the tablet use, the augmented reality tablets, and having that platform there as well for after hours homework and those types of things. And then you see DMI bringing in some of the AI part, the coaching, the interaction that kind of goes along with the VR aspects into this with the hands-on tasks as well. So in the headsets, turning wrenches and doing things in the VR for maintenance tasks was done by DMI. And then C-Square Technologies was kind of brought in to kind of bring this all together to kind of do the assessments and kind of connect all these things together to create this learning experience. And so with our partnership through AFMS and then understanding this partnership we have with C-Squared, we were asked to kind of help do the assessment and kind of look at how effective was the first prototype of maintenance train next. And so we were brought in, and some of our students and I, we looked at some of the feedback from that first group of students. And so as we look at the feedback, you can just you can see some of the comments in blue, if you will, that talk about some of the feedback from the students. And what we started to recognize was there's some disconnect to some extent in how effective they thought it was supposed to be. and how effective they thought it was going to be, and it maybe didn't get there like they thought. And we're like, well, how is this possible? Because we just came from Pilot Training X and PTN and all the great things that was being pretty effective in that industry and helping airmen in their pilot training. So bringing that same kind of thought process into maintenance training, we should probably see the same effect, if you will. And it wasn't as strong as they thought. And so why was that? And as you look at some of the blue comments, you'll see a lot of questions like the task isn't the same. The big parts that you see is the students asking the why question. Being in those immersive technology events and activities and experiences, the students weren't given the why because they're in there doing something in the headsets or the task just doesn't explain it to them. Or as you see on the right side of the comments, students were actually wanted to do more interaction with their instructors. And some of that was actually being pulled away as they brought in the kind of the maintenance train X thought process. So more stuff was happening in kind of the immersive technology, and maybe less conversation and dialogue was happening between students to instructors and students to students. And so we started to see that maybe these are some of the reasons why it's not as effective as they potentially thought. And so that led us then to kind of think about, well, so what's going on here? Why is this not as effective? And so as we kind of looked at the overall flow of the course, maintenance train next, as you see here on the left side of the slide, students go through the learning basics. They go and they use VR to do that, and then they do some desktop AR type stuff, and they do some more hands-on VR stuff, and they do some more follow-on kind of maintenance progress checks in VR, and then they get their block test. And then during that whole time, they're doing on their own self-studied using augmented reality, taking tablets home with them and going through that process. And then there's this now validation part where the instructor then starts to validate. They look into the MOTAR platform, the LMS systems, to see how the students are progressing. And when they're ready, they give them their kind of quiz, and then they get their hands-on validation. And so I think what we started to see as we started to assess this through the research task force was that there's just a little bit of a disconnect on the affective state of the student. How much self-efficacy do they feel graduating out of the program? And so that came up with this idea of, well, what are those things that are actually allowing for affective state that we know from learning theories that connect to immersive technology? Experiential learning and flow theory and transactional distance theory as the research that the RTF and our students did research on to connect the dots. And from that connecting the dots, we were able to recognize that maybe there's a missing gap in when we bring in VR or immersive technology into a training program, and that maybe there's more than just ISD or bringing VR and putting something into VR from going from the real world experience and taking it to a VR experience. There's more going on, and we have to understand what's going on in the mind of an individual when that occurs. We have to understand that why, and so that's what started the process. And so we gave feedback to maintenance train X on that, presented those slides, if you will, to ITSEC in the paper, which you'll see from here. Go back one, sorry. And then from this, when we briefed this concept at ITSEC, we ran into people like Lieutenant Colonel Tracy Schmidt and making those connections and just talking to them during our presentation at ITSEC. And Lieutenant Tracy Schmidt's like, this might be somewhat potentially useful or as a thought process as we look at actually pilot training going forward. And so that's how we kind of met Lieutenant Tracy Schmidt and Major Moore on maybe this model can not only be applied just to maintenance train X, but to other training programs. And so that's where we brought in or made that partnership or collaboration with 19th Air Force and Lieutenant Tracy Schmidt and Major Moore. And so we're going to talk about then how we took this concept of assessing maintenance training next and saying, hey, this thought process, this model of flow theory, transactional distance theory, and experiential learning theory all wrapped up together to create this flow experiential driven concept that could be applied in other areas, training programs within the Air Force. And that's how we see the application then into 19th Air Force. So I'd like to pass it over to Colonel Tracy Schmidt to talk about how they see what's going on in pilot training and then how potentially this foundational model has been supportive.
Great. Thanks, Dr. Clayton. So I guess I'll start by saying pilot training has been on this journey for a few years now, and I've been on kind of a personal journey of, learning what does learner-centric learning actually mean. And And we'd come up with a lot of ways we were going to go about improving our training. And I was so happy when I saw Dr. Clayton's presentation at ITSEC, because I thought, oh my God, that's what we're trying to do. We need to do that. So I'll start by sort of explaining the why, because that's important. Pilot training is trying to change. And you can see the slide there. It's a picture of a class patch. Every class makes a patch unique to their class, and they're all different things. I happened to see this one posted up on the wall of an FBO somewhere, and I thought that pretty much sums it up. I have to be careful about how I say this, because we are the world's greatest Air Force, but we're not without our shortcomings. And the biggest problem that we have with our pilot training programs is that our students graduate being able to perform the tasks. They can make it look right, but they don't necessarily understand how they're doing it. And they get off to their follow-on training programs. They go to a new airplane in a new place, and now that the environment has changed, they don't know how to translate what they learned in UPT to where they've gone. And so it just takes a whole bunch more time and hours and supervision, being co-pilots or wingmen in future training programs, to really get them to where they have this concept we call airmanship, right? Being able to understand where you are, what you're trying to do, and make really good decisions related to what you're doing with your airplane. And it's a frustrating point for our instructor pilots too, because they find themselves telling the students the same things over and over again, and the students aren't really getting it, and they don't understand why. So I started doing some instructor training to explain to our instructors, what does learner-centric mean and how does it change our programs? And this video won't play, but it's hilarious. If you Google exact instructions challenge peanut butter and jelly, you can watch it. It's about 5 minutes. But I guess this stuff comes from the computer programmer world, where when you're typing code into a computer, it's only going to do exactly what you tell it, and it doesn't know all the inferences that you're not making or the assumptions. And so he has his kids write exact instructions for making a peanut butter and jelly sandwich, and he ends up putting the whole jar of jelly between the two pieces of bread, and he sticks the knife in the jar handle first, and the kids get so frustrated. And so I use this to connect with the instructor pilots to go, okay, this is what we're doing in UPT. We're trying to give our students exact instructions about how to do the tasks, but like Dr. Clayton said, we're not really telling them the why or the how would they know that, or how would they make a decision about it. And the result is instructor pilots love memes. So I'll let you read that for a second. So we spend all this time telling our students how they should be doing things. We go fly, and at the end of the sortie, we thoroughly cover everything that happened and what they need to do differently the next time. And the next time they go out, and what do? They just do it all wrong again. And then this is where I'm going to hand it over to Carolyn. She's going to talk about the human performance side of it first, and then I'll get more into the actual learning design of it.
Great. Thank you, Matrix. So what we've attempted to do as we've totally transformed pilot training is to move towards the learner-centric, student-centered learning, better implement AR and VR to provide more reps, more opportunities for students to practice what they're trying to learn from the IP in a low-threat environment, and also to implement a human performance side of this as sort of the underpinning for the success of the rest of the program, right? Because with all of the AR and VR, all the student-centered learning, if a student is not able to focus because they're tired, if a student is too busy thinking about the last sortie and all the mistakes that they made, and they can't focus on the next or the upcoming sortie, if they can't do these things and don't have the ability just at the very basic level to perform, then all of the rest of this stuff layered on top is not going to be effective. And so one of the very basic underpinnings of all of PTT has been to provide this human performance, embedded human performance optimization. But realistically, you can think of it as prehabilitative for operational stressors. You can think of it as a wellness program. There's a lot of ways that you can think about what we're doing, but it's very basic in the idea that if the human is not taking care of themselves, they're certainly not going to be able to effectively accomplish complex tasks. They're certainly not going to be able to retain information over time. And so with the implementation of what we call the CRAFT program, we've provided the students with strength coaches, cognitive performance specialists, which are typically folks that have a master's or even a PhD in an area like sports psychology, and then registered performance dietitians. And through this, we provide the embedded support in a variety of ways. One, we provide academic instruction to the students. So in the first phase of flying training, they'll get about 8 hours of academic instruction. And then depending on which type of aircraft they will eventually track to, they'll get another 10 hours or another 6 hours of academic instruction. And it covers topics on fitness, diet, sleep, and fatigue, mental performance, as well as resilience. And on top of that, we provide the students with training regimens to support both their cognitive and fitness training. We provide them with equipment and tech that enables access, regardless of whether they have the ability to interact with one of our specialists that day. And they do have a requirement in their syllabus twice a week to spend time on what we call a craft event. And it's left intentionally open-ended so the student can decide, today I'd like to do a mindfulness session. Tomorrow I want to go do a workout. But whatever they feel they need to work on. And all of this helps support the culture shift to student-centered learning. We want to get the students out of things like habits of just sitting in the flight room for 6 hours straight, studying pubs and staring and reading the same sentence over and over again, but not absorbing any of that information, right? Learning better techniques to retain information, as well as retain that information so that you can build on it later, right? A lot of our students are directly out of college. They don't have great study habits. They have enough study habits that they can pass their college classes, take a test, and then immediately brain dump all of that information for their next class, right? But that's not what we want out of our pilot training program. We want them to retain the information and then build on top of that base information to make them effective decision makers, to make them able to solve those complex problems they will face in the flight environment. And so being able to support that human performance optimization goes with being able to support that culture shift to the student-centered learning. And we also focus on the IPs techniques as well. So on top of focusing on what the students do, the students get all of this required human performance in their syllabus. The IPs also have access to this. In addition, we started implementing this program in the training where the pilots learn to become instructor pilots. And we've also started to implement it in our advanced instructor course, which is where some of our experienced IPs come back and learn even more improved instructor techniques, right? But getting them out of the mindset of asking, does that make sense? Or do you understand, to the students in a debrief? That's not necessarily effective. And in the history of students, no student has ever told their IP, nope, that didn't make any sense to me, right? They just nod their head and say yes. Getting them to better effectively facilitate conversation with the student. So instead of saying, does that make sense? The IP can say, repeat back to me in your own words, or describe back to me in your own words how you will do this differently next time, or what did you do that made you successful? And it makes the student think about, what did they do? What steps did they take? Why did they make the decisions that they made, right? So now you've got a facilitated discussion to better help the student, who sometimes understands why they were successful and sometimes they do not. They know that they did the right things, but they don't even exactly know why. Now you've got a facilitated discussion between the student and the IP, which obviously moves more towards better retention and better understanding of what the student is doing, right? So we support all of that through this program, but in particular, on the cognitive performance side, this is where it really centers around that shift to the student-centered learning. Also, again, getting the students into a state of flow so that they can effectively utilize the AR and the VR, and the access that they have to all the technology, right? The student is not ready or in a correct state of mind to learn and retain information, they're not going to, right? And so cognitive performance is one of the areas we get a lot of our questions on. And these are just some of the primary topics that we discuss with the students, either in our classes or when they do their one-on-one sessions with our cognitive performance specialist. But you'll see that that second one on there is flow, and trying to get students into a state of flow so that they feel at ease. They're better with mistake management. Flow and mindfulness and mistake management, all of that goes together, right? Being able to recover from some sort of mistake, being able to understand, especially with mindfulness, of being in the present moment rather than being stuck in whatever I'm going to be doing next or whatever just happened. Attention management and cognitive load, learning to understand task management, all of those things are things that our cognitive specialists can work on with the students. And our cognitive specialists can't work with the students in the aircraft. That's really strictly related to the IP's realm, but a student can go get into one of these VR sims and work with one of our cognitive specialists. And we have found that having the ability for the cognitive specialist to go sit with a student in a sim and in VR is very helpful. We found that we can help with students with things like altitude holds or radio calls, right? Those are all task management skills that the cognitive specialists can better improve the student's performance. And so it may not be immediately obvious to an IP that, well, the student's struggling with their altitude hold, they should go see a cognitive specialist. But having a cognitive specialist present can help facilitate those things and help get that student into that state of flow. And so what we see is that with the shift to student-centered learning and with the assistance, particularly of the cognitive specialist, but really across the board with the human performance optimization, that helps us integrate all of these concepts of PTT into one learning architecture. And so the flow-driven learning experience design really helps us create that architecture, that backbone of what it is and how human performance and student-centered learning in AR and VR all work together to build confidence and competence for our students, and over time provide stress inoculation so that they become better and better in more stressful situations. And this is where I'll turn it back over to Lieutenant Colonel Schmidt.
Great. Let's see what's on the next slide. So again, this is tailored to, as Dr. Clayton's comment says there, when you teach people things, you got to tailor it to the audience and their personal experience. And I don't know what y'all's personal experience is, so I'm just showing you what I've used to connect with our instructor pilot force. But they start with the craft, with the support for the affective and cognitive portions of learning there. And then when I try to explain what we're changing about our training from the way it's always been is, and I don't know how many of you out there maybe already know this, but I'll just briefly explain it anyways. What we've always done is I call it teacher-centric task-based training, where the teacher-centric part of it is, it's a lot of one-way communication, the teacher imparting their knowledge, students supposed to read the pubs and listen to the lecture and just memorize everything. And then that's magically going to turn into an ability to perform a skill, which we know from modern research is not true. What we're trying to shift to is the learner-centric competency-based model, where I think of it as task versus competency-based. Is more about what you learn, not just the task, but how do I have situational awareness about all the different variations of how that task can happen and make decisions and tailor how I do it appropriately to the situation that I'm in. Like landing on a wet runway is a little bit different than landing on a dry runway. Whereas the learner-centric is more about the method of how you learn those things. And so there's kind of two comparison points on this slide. One is what we've always done is knowledge transfer. We just think we can just dump it in the student's head. It's that exact instruction challenge. If I'm just precise enough, then they ought to get it. Whereas in a learner-centered model, it's really more of a construction process. And I explain it as, you as the instructor have a lot of knowledge, and you could think of it like building materials. You can give the student nails and 2x4s and even a blueprint, but you can't build the building for them. It has to be done by the work that's done in their head through all of these active learning activities that we're going to build into our syllabus. And the second point of comparison is what we've always done. I call it learning skill by osmosis. If you just go sit in the jet for enough years and hours, your brain will eventually figure out what's going on and then you'll be competent. But that takes a long time and it's frustrating. So what we want to do is incorporate the idea of deliberate practice, where you're setting specific goals that push you a little bit beyond your comfort zone. You have the tools, the training program, the tools, the instructors, and the study habits to focus intently on how you're going to prepare for that. You need high quality feedback, right, on whether you did it well or not, and ultimately developing a mental model of expertise, which goes right back to that knowledge to construction. And, it's not just facts and definitions you need to know, but it's that what situation am I going to be in? Why? What's important? How am I going to use this knowledge real time in the skill that I'm doing? So then this is the graphic on the right is from Dr. Clayton's paper, and I put that up there to explain the basic idea. But I compared it to some books that are out there that people have read. Atomic Habits, they talk about how people need motivation, achievable goals, novelty, and a reward to really be motivated to learn something new. They talk about how it needs to be 4% harder, which is, than what you're capable of handling, so that it's a little bit challenging, but not so much that it's demotivating, but enough to push yourself. There's a great book called Make It Stick that talks about how 15% of your attempts should result in failure. And that's the appropriate level of challenge. And as Carolyn mentioned, the whole point is to get them to perform to a high level under stress. So for UPT, if you take that and break it down kind of to what I just said there, the things that we need to change are, one is we've always focused on getting a good grade. So the students are always trying to do the easiest thing they can to get a good grade, and they're not challenging themselves. We don't really have specific goals. We have end of course goals, but nothing that really guides you along your path there. The system is set up, they have to pass these check rides, but what they end up doing is just flying the check ride profile over and over again. And it gets boring. They don't get good at it, but it's not novel, right? So they're not really improving. We give them feedback, but we could improve our instructors, and responding to feedback is that growth mindset that Craft is trying to teach them about. And particularly for the instructors, we need to talk more about just the rote knowledge they can read out of a book and more of the higher level knowledge. And so I put that on that chart on the left side as kind of deliberate instruction, where we spend a lot of time helping them, giving them real-time input, but what we need to do is prepare them for success using the right kind of academics, the right kind of VR training like Dr. Clayton talked about, and then go out in the airplane, and it's really a test of what they learned, where the instructor is going to do some coaching, but then essentially back off and see what the student can do by themselves, trying to always get them up to the point. The red line is the head fire. We call it a helmet fire, where it's just they start to fall off the cliff because they can't handle what's going on anymore. And that's how we know we need to go back and reset our coaching to improve that. And there's a lot of misconceptions about what we're doing out there. The bottom part of that graph is what people think we're doing to pilot training. They think we're making it easier. And they think learner-centered learning means that you just help the student more, but it's actually almost the complete opposite. And so to tie this all back to Dr. Clayton's model, I kind of briefly explained. I basically said, I'll give you the paper if you want to read it, because our pilots are frankly not ready for this level of academia. But what I did was I took the graphic on the right side and I turned it into something that would be more familiar to pilots. So they're all familiar with knowledge and experience. You're going to get, except it's not just book knowledge and just getting in the jet and learning by osmosis anymore. The knowledge is that whole construction process where you've got to go through the levels of learning, doing interactive, collaborative type things, using the VR where it's good. Going out in the jet, you've essentially built a hypothesis, and now you're going to go test your hypothesis, get the feedback on how well it worked. One of the emphasis points is people think that the learning is happening in the debrief, where you're just really what you're doing is giving the student more 2x4s and nails to hammer into their house. But they can't actually do that in the debrief while they're sitting there taking notes on what you're saying. So that another big piece of what we're trying to add to pilot training is this idea of reflection time, giving the students actual time and a structure on how to use that time, rather than just, as Carolyn mentioned, reading the same page over and over again, trying to memorize it. So we are trying to build out, a series of exercises where they can use the knowledge in scenario-based training, problem-solving exercises. We have the immersive content goggles that you can wear, as well as the virtual reality simulators. We talk a lot about chair flying, sort of mentally rehearsing your last sortie versus your next one, and what tools you use to do that, so that you're really taking what you learned in your experience and turning it back into knowledge that you can use for the future. And I think that might be my last slide. Let's find out here. Yep. All right. I will turn it back over to Dr. Clayton, I think.
Yeah. Yes, perfect. Thank you. Awesome. Thank you. Lieutenant Colonel Schmidt, thank you. And our last slide here, we can kind of hold also with, as we go into Q&A, but these are some of the things that, as our team has kind of looked at of things potentially in the future and what the future holds. And as we look out at industry, things that are on our, in our heads, is, as we look at the future, more real-time data tracking, and these things are out there, but a lot of times it's the data's there and then you have to go download it and then do something with it and program it to do something. And actually what needs to happen is that data needs to be live and easily accessible for instructors and students to be able to access as things are happening, as compared to getting this data afterwards and then having to do something with it and pull it down and make something out of it first, and then be able to use it with a student or instructors and stuff. So we call this the live real-time data tracking for human performance type stuff. And then obviously, as you look across programming and different VR experiences, there's got to be this ability to actually have more of this kind of plug and play from one type of VR experience or simulation and be able to bring something onto it that might be from some other industry organization, and allow those to communicate and work together more efficiently and seamlessly to be able to do those types of things. And then integrate, obviously, those immersive technologies with more of the learning management systems. And I know there's things like Motar and some things like that, but it's got to be even more robust and it's got to be more connected and seamless. And then some other future stuff that we're looking at least from the research task force on our side, is what we call multi-career field simulations. And so what this means is you take something like, for example, pilot trainings simulations and maintenance training simulations, and you create a simulation where both are in what we call a metaverse type simulation. And so you have multiple career fields in the same sim doing the simulation together. So it's not stovepipe simulations for specific stovepipe training, but it's kind of done together, all domain simulations done together. And then some of the research we're doing in the future is on adding into this model more of what we call the immersive taxonomy. And we're doing research with some other universities that are looking at some of the first taxonomy charts and publications of immersive taxonomy and what does immersive learning actually look like. And there's a taxonomy out there that's been published and approved, and we're actually applying this in different ways right now through some professors from San Diego University and a company called Access VR that published the first immersive taxonomy chart. And then looking at that, and then looking at programs like we did with Maintenance Training X and others in the same way we did with this program through the taxonomy, and seeing how to improve the immersive experience by looking through the taxonomy chart and stuff. And so we're looking at that right now. So that'll end kind of our presentation. Totally ready to have conversations. Hopefully that wasn't too much, but totally want to open up and have an open conversation about anything and everything.
Thank you. My goodness, that's so much great information. So we did have quite a few pre-submitted questions, as many of you saw, and obviously we have pretty active chat and Q&A online today. Some of the pre-submitted questions were Air Force specific. I want to sort of zero in on those, and a couple of them actually had to do with taxonomy, which you've pretty much addressed. What taxonomy does the 19th Air Force PTN currently use, and what would be useful for the future? And then what VRAR taxonomies do you see are applicable to our pilots? So I think with your statement there, and I don't know if you have a link, Dr. Clayton, that you could share or upload the paper with the taxonomies.
Absolutely, yes. There's a published paper, and then I actually just received a pocket guide of this immersive learning taxonomy. And so we're kind of going into phase 2, actually, with this taxonomy in partnership with Shenandoah University and Access VR through the RTF to build what they call kind of like a interactive tool. And so so you can go into a web-based version of this taxonomy, and then as you look at your training program or your immersive training program, and you go through and look at which parts of the elements of the taxonomy are actually you are applying, or if you want to build an immersive experience using immersive technology, what immersive elements do you want? And as you click through these, it will actually tell you what parts of industry are actually doing this. And so the great thing is we're trying to build that kind of that library across industry as well. So as you click through that, it actually communicates to that user, one, how to communicate through the taxonomy, but two, what industry experts and organizations out there are actually developing the different elements of this immersive technology that you want to get after. And so I think it's a great way to, in our researches, we're trying to consolidate all of that. But I will send out both the paper, the pocket guide, and some of our phase 2 research that we're starting to do on actually now interactive use of the taxonomy and who out there in industry is actually meeting these elements of the taxonomy.
Excellent, thank you. Did we have a couple questions related to more the instructional systems design or instructional framework, and where does those roles fit into helping determine right immersive technologies in this flow theory scenario?
So that's a great question that comes up often, and I think even as we were writing the paper and looking at this model, and I think even with 19th Air Force, right, there is ISD, right, almost any training program out there that whether it's military or any other training program, educational training program, there are ISD. That's where ISD came from. There's the ADDIE model. There's these types of things for instructional design. But what happens with instructional design, it becomes very structured, more of a step-by-step kind of way of looking at things, and it looks more at the performance of the course, the outcome. So ISD focuses more on the performance that you want your students to get out of the training program. What the flow learning design thing, or if you just look at learning design experiences in general, or even some of the student-centric designing with 19th Air Force is doing, is it focuses on the experiential process, right? So an ISD doesn't always encapsulate that or captures that, because in the learning experience design process or student-centered design processing, it's more fluid. It potentially probably is a little bit more circular as compared to ISD, which is more linear and looking more for at the performance. What is the intended improved work performance of the student, of the participant? And learning experience design, you're looking more at the affective state of the person and the experience that they're going through. And like Lieutenant Colonel Tracy Smith mentioned, we're trying to get the students to understand that the why as well, and how they do it. Instead of just doing it, instead of just doing the performance, what is actually occurring in the person's brain? What are they processing? What is that affective state? What flow are they in? What are they thinking through? What is the experience that they're having? And those are important. And sometimes that isn't captured in ISD. So I can ISD and say, here's what I want their work performance to get to, but how they do that comes from a different process. And that's what 19th Air Force has done a lot with, as you heard from Major Moore with craft, and then obviously with the student-centered learning experience design, and then we bring in this flow theory. These things all make that kind of concept come to life, whether it's in a traditional training environment or if you're going to bring in the VR part of it. So if I even bring in immersive technology, I can go through the ISD process and go, can the VR help them to get to that intended performance, to land a plane, to do in-flight emergency checks, whatever that is, can I do it in VR? But then you have to look at, okay, even though I've got the student in there, what is the experience of going through that? What is their affective state of mind that the student is going in the VR? So I'm meeting the performance through the ISD, but now I have to understand the experience that the person's having in the immersive tech experience. And that's how you see the differences between the two.
Are there certain forms of, is it VR, AR, and we use this term XR, which really is kind of is meant to be kind of an umbrella term, VR, AR, MR, all that. But is VR more of a focus or AR more of a focus, or can you say?
Yeah. Well, And it kind of depends in the industry, and so and where you're at. So I always, when these kind of questions come up, I always think of, are you asking more from an educational perspective or training perspective? And so I think you'll see the uses a little bit differently. As 19th Air Force, right, they're focused on training. And my research at Air University, all my focus and my students are all in education. And so the uses will be different. For education, it's mostly in VR. In training, like you see with Maintenance Train X on the slide I showed you, there was 5 or 6 companies that were all having a different aspect of immersive technology. Some were building the VR, but they also added augmented reality into the training program. And so you see the uniquenesses of the differences, and even some mixed reality with 360 videos with artifacts and stuff overlaid on top of the 360 videos. So that's our mixed reality. So training for Maintenance Training Next, the training, they used all 3, VR, AR, mixed reality. In education, most of Air University, all of what we do is in VR. And so now if you look in industry in the future, if you look at, let's take one of the biggest companies that's using like immersive tech, Facebook or Meta, whatever you want to call them, right? Their new headset is getting ready to come out soon, and it's called Project Cambria. And there's a video out there of the CEO, Mark Zuckerberg, with the headset on, but in the video, the headset's actually blurred, so you can't see what it is, but they show you what he's seeing inside the headset, and it is a mixed reality view. So it's no longer VR. So even Meta, they're going from their VR headsets, the Quest 2s, into a mixed reality headset. And I think that's the industry that you're going to see, is that you won't have just VR headsets. Now they'll be used in training, things like that as they go forward. But as industry is going to move forward, especially for consumers in general, it's going to mixed reality headset that allows you to do both augmented or kind of a mixed reality with VR. So you can switch it within the headset to do a pass through and have augmented reality stuff, or switch it where it's now VR. And that's what the new headset from Meta is, which is called Project Cambria.
Mm.
So that's not sure. Nobody's really sure where it's at, but
Right. You have unknowingly actually answered one of the interesting questions that was pre-submitted, which is, do we see all these versions of reality, virtual, augmented, merging into single platforms? And as you've just indicated, that's kind of, when you talk about metaverse, it exactly does that.
Yeah, it will be a mixed reality, and then obviously extended reality is kind of encapsulates all 3, AR, VR, and mixed reality. But what you're going to see is you're going to see mixed reality headsets coming out, and I think Meta is going to be the first one that's going to come out with stuff first. And you'll see even like Snapchat and stuff has AR, VR, mixed reality type headset. So that's the industry. Now you're always going to need the VR, going to be there, especially when you just need it for training purposes, and I don't need the mix of the two and stuff like that. But overall in consumer, the consumer is wanting the mix. And so they can switch between the two. And so now then is, how can I apply this new type of headset, if you will, into training programs, educational programs? Because now it's going to be a little bit different in how right now, or most education stuff is done in VR, or if you want AR, you pick the AR kind of headset.
Do you see, and this gets to one of the other questions that was submitted, and that is around common standards and open architecture. As I shared with those of you on the panel, I'm sitting in Tech Grove, and we have the whole Air Force SCARS team in here, which is working on that common framework to enable all sorts of devices to work together much more readily and software-wise. Where do you see happening with these kinds of tools out there so that they can be utilized together more effectively?
That Lieutenant Colonel Schmidt and Major Moore may have a little bit more potentially experience, just as in probably using multiple systems or crossing of systems and things out there. If you look through AFMs, right? AFMs, right? One of their major things is creating that common synthetic environment, right? At the operational level of simulation. So Air Force and Navy, right? When they're in their sims, right? And they can be both in the same common synthetic environment and do that joint, kind of simulations, exercises, if you will. But, within training programs like that, right, there are multiple systems that are occurring, and sometimes that can be an issue. Lieutenant Colonel Smith and Major Moore may know more from experiences of working with all this different types of immersive technology to help in pilot training, for example.
Can you remind me what the original question was?
Oh, Carol, you're on mute.
Yeah, I think you're on mute.
Okay. The question was that do we see a push towards some common standards and requirements that we get away from vendor lock, basically, where various devices could interact together, be used together much more easily, and you're not required to stick with one vendor's software and API and all that.
Yes, that's definitely where we would like to go. One of my inputs for the ask to the tech community was that we would like to go that direction. We don't want to be in vendor lock, and one of the things we've sort of struggled with is getting things to integrate, but we're trying to build a cloud-based platform where everything is, the learning management system, all the courseware and everything the students would access is out there, and the simulators, and the whole thing can have third-party applications that just would plug and play into it, because, there's no one company out there that has all of the exact solutions that we need. And so if we can take the best of each piece and plug it together, that would be awesome.
Thank you. And Major Moore, there's been some fascination among our listeners with this term cognitive specialist. And
Yes.
as we listen to creating a mental model, your area of expertise and how you view an individual student and all the aspects you look at obviously becomes increasingly important. So how does someone become a cognitive specialist, and how are we going to create more of you?
Yes, that's a great question. So, and actually it came up, I was doing this just last week and had kind of the same question. What are the standards, what are the requirements to become a cognitive specialist? So as I mentioned, the main requirement to be hired into our program is that they have a master's degree in some sort of applied psychology. It's often sports psychology, but you can get folks that have industrial or organizational psychology backgrounds. But the idea is that they have this background in an application of psychology. So it's very different than what we think of as traditional psychology, which would most people think of a clinical psychologist, where they're diagnosing or treating adjustment disorders or mood disorders or those types of things, right? Or even something like a marriage and family therapist, right? Our cognitive specialists don't do any of that stuff. So we do resilience, but all of it is performance directed, performance related, right? So we'll talk about mindfulness, right? So mindfulness is a really great tool to help you stay in the present moment. It's a really helpful tool for mistake management. It's really helpful for recovery from failure and a growth mindset, right? It can do a lot of things for you. A lot of times the students get into their heads and overthink things. If they do make a mistake, they'll keep thinking about that, and then they pile on more and more mistakes because they haven't gotten over the first one, right? Mindfulness is a tool in the toolbox that can help with a lot of different things, right? So we focus on it from a performance perspective, but can you use mindfulness in other aspects of your life? Can you use it for marriage stress? Can you use it for other types of adversity? Absolutely, you can, right? So there's a little bit of a blur in between what a cognitive specialist can do and what we would consider kind of traditional resilience, which gets a little bit more in the mental health realm. But our folks are strictly really on the performance side. And so then on top of having that master's degree in some sort of applied psychology, and if you ask them, they don't call themselves psychologists either. They'll tell you, I'm not a psychologist. And we try to avoid using the term psychology with pilots. That gets them a little weird too. So we will send them to trainings like there's a program called Peak Mind. It's a book, actually, that you can look up. It's by a professor at the University of Miami, and it's all mindfulness-based training for performance, right? And so we can send our folks and have them do mindfulness-based training. And so one of the things that we do with Craft specifically is that I actually provide funds to the contractor to get our folks trained on the same things so that they're all trained to the same level, right? So they may all come with this applied psychology background, but then we sort of train them up. There's another program that we use called Heart Math. And you can use M-Wave, what's called an M-Wave technology, but it's basically just a little thing that clips onto your ear and monitors heart rate, SpO2, and from that you can extrapolate things like respiratory rate, which then can also help extrapolate students' cognitive state, right? And I'm not talking specifically like, are they overloaded or overtasked, whatever, but if their respiratory rate and heart rate are high, then there's a high likelihood that they're more stressed, right? And that gets them out of what we call coherence, right? And so going back to mindfulness, something like a guided breathing, right? You can regulate your breathing, which helps you regulate your heart rate, which helps bring your stress level down, right? So those systems work together, right? So if you get mentally stressed, your heart rate will increase and your respiratory rate will increase. You can reverse that process just by focusing on your breathing. If your breathing rate slows down, that sends a signal back to your brain for that stress level to decrease too. And so we get our cognitive specialists trained on all of these same types of tasks through the contract. But one of the things we've actually, if anybody's familiar with the Army's Master Resilience Program, it's based out of the University of Pennsylvania's Positive Psychology Program. And if you can go Google University of Pennsylvania Positive Psychology, and they have a page that talks about a lot of this stuff, grit, resilience, again, growth mindset. And so a lot of what we've done when we've hired folks for the cognitive performance specialist program or portion of the program is that we've actually ended up hiring a lot of these folks that are trained through the Army's Master Resilience Program in the UPenn positive psychology architecture or program that they have developed, right? And actually that entire program is based out of research that was done by someone that was a former flight surgeon. And she was actually ended up as a POW at one point in time. And after that experience, went and did and learned a whole lot about post-traumatic growth rather than post-traumatic stress, and how do you, instead of somebody going into the post-traumatic stress disorder, how do you get them and coach them towards post-traumatic growth instead, right? And that's what a lot of the UPenn psychology is based out of, is her research. And then the Master Resilience Program from the Army is then a subset of that. So that's kind of it. It's not as defined, say, as like a strength coach. They get their CSCS, right, from the National Strength and Conditioning Association, and they're certified, right? So the cognitive realm is a little bit more nebulous. But those are all the things that they can kind of focus on and help students with. And then again, it goes back to, then we've got somebody who has all of this background to be able to better facilitate the training in the ground environment to help with, as Dr. Clayton mentioned, the getting them into flow, the stress inoculation, helping to gauge the task's difficulty for the student and then adjust it, right? So working with the IPs and working with the students to utilize the technology effectively with their understanding of mental performance and the ability to assess a student from, heart rate or respiratory rate. And that's why something, as Dr. Clinton mentioned earlier, and I'll throw out there about eye tracking, right? Having the ability to see what the student is looking at, what they're focusing on. Are they channelized on a particular thing? Is it the right thing, right? That they're looking at or focused on? Is their scan pattern effective? Cognitive performance specialists can help with all those things. So something like eye tracking in the VR with a real-time output, but then also the ability to easily take that information and use it later in a debrief, right? And those are some problems that we see as we've been looking at eye tracking. Those are difficulties that we've seen running into easy application of the technology. And again, that open architecture of making all of these different systems work together with each other, and then downloading that information into human performance databases, right? So we can marry it up to other data and telemetry data from the flights. All of that has been a really difficult process to try to get all these systems to speak to each other. So I don't know if that answered the question.
Well, you've tied together a lot of different pieces very well. So thank you for weaving that section of the tapestry here. But we just have a couple minutes left. Russell Hutt, I know you're on the line, hopefully. And as the sponsor of this fascinating research that is continuing to be developed, where does Athens want to take this? What are your plans for moving this forward and to actual utilization?
Yes, thank you very much. Yeah, that's a very good question. As a matter of fact, we are actually using it So next month, we are actually hosting and collaborating with the FTU, Force Fighter Training Unit, and the units themselves, ATC and ACC units, in that very effort. So as part of that innovation workshop, they're looking at not just the proposed framework that was mentioned in the paper, because it's based on that experiential theory as well as the principles of flow, but looking at the immersive technologies, seeing how that collaborated and focused on the understanding of the FTU syllabi based on the performance measures, the objective readiness measures, the total learning architecture, and the adoption of AR, VR, and where that's going. And as one of you alluded, also the larger picture, the future picture of synthetic environment for the Air Force. Thank you. Over.
Thank you. So one of the things I love hearing about this wonderful innovation that was presented in a paper at ITSEC, Dr. Clayton and your team, you're continuing to move this forward, you're evolving it. Maybe we'll get to hear you at ITSEC this year with the Flow Theory 2.0 presentation. And as we've heard, AFMS is actually beginning to move forward and integrating this into actual applications. So we are, goodness, unfortunately, we're at the end of our time. I think we could go for another hour. There were so many wonderful questions that were presented we did not get to. I apologize to those of you that asked such great questions, but thank you all for being here today with us. Follow us on LinkedIn, Central Florida Tech Grove. Be sure you fill out that contact form on our website so we can keep you abreast of the coming webinars. I'll get those from NTSA. We have our SBIR, STTR Partner Showcase Day coming up June 30th, showcasing recipients of SBIRs and STTRs from our Tech Grove customer agencies. So lots of things going on. And Dr. Clayton, Lieutenant Colonel Smith, Major Moore, and Russell, thank you so much for being with us today. Appreciate your time and looking forward to hearing what's next. Appreciate it.